Hello class, welcome back to another section of our intensive calculus course, still on applications of differentiation. In this class, we're going to do critical values. Critical values. Basically, in elective mathematics, we say stationary point. So this is an interesting application of differentiation in which we find critical values or maximum or peaks in a function. If I have a graph represent a curve like this, you realize that in the curve there are certain points where there is a turning around or there's a change in direction of the curve. The curve was rising from this side. Upon reaching here, it stopped. So meaning at this point there is a resting phase here, then it changed direction down, and at this point there will be another resting. So those peak points are called the critical values of the function. How do we get those functions? Initially, we said the derivatives is simply gradient, yes. The gradient from this side keeps on changing, but at this point, you realize that the gradient here becomes 0. It doesn't change because there's a resting here. So that means that to find the critical values, you just find the f of x over the x, and it should be equal to 0. So every value which you get here will be a value in which there will be a resting, or there will be some kind of turnaround. So we call critical values or turning point or stationary point in a function. So you know when you say something is stationary, it doesn't move, yes. Therefore, the gradient there is going to be 0. That is basically the meaning and the understanding of critical values. So I have some functions here which you're going to find the critical values of. First function, I have f of x is equal to 10x squared plus 4x. I have this curve. They said I should find a stationary point where the points are not moving, meaning the gradient is 0. So I'll just find my gradient function, f prime of x, and it should be equal to 20x plus 4. So once I have 20x plus 4, then my stationary point will be the point where this gradient function will be equal to 0. And my point is going to be 20x is equal to negative 4. X will be equal to negative 4 on 20, which is equal to negative 1 over 5. So negative 1 over 5 is my stationary point. And at this point, the curve is not moving. That is simply how we find critical values. Let's take another example. I have f of x is equal to 6x to the power 5 plus 33x to the power 4 minus 30x cubed plus 100. This is quite a long function, and this curve is going to be wavy a lot. So our gradient function f prime of x is simply equal to 30x to the power 4 plus 33 times 4. What is 33 times 4? 33 times 4 is 132x to the power 3 minus 90x squared. Then this will be 0. When you differentiate a constant, you get 0. So once I have this, my gradient function, I simply equate it to 0 to get my critical point. So I simply equate this one to 0. So once I have this, I just solve for the values of x that will make this function 0. I'm going to factorize x squared out. When I factorize x squared, I think I can divide through by, is there any number I can divide through? 4, 6. So I think I can divide through by 3. So 3x squared out, I'm going to get, so if I have 3, 1 through 2 on 3, 44. I'm going to get 3x squared out. Here will be 10x to the power 2 plus, here will give me 44x minus 30 close brackets equals 0. I think I can still divide here by 2. When I divide here by 2, I'm going to get 6x squared open bracket 5x to the power 2 plus 22x minus 15 equals 0. At this point, I can see that 6x squared is equal to 0. My x is equal to 0. Then 5x squared plus 22x minus 15 will also be equal to 0. So we find the values that will make this function equal to 0. 5, 22, then negative 15. Then we are getting 5x minus 3 multiplying x plus 5 is equal to 0. Therefore, my values of x is going to be 3 on 5, then negative 5. Therefore, the critical point of this function is given by 0, 3 on 5, then negative 5. This is how we find critical values when a function is given. I said critical values are also called stationary points, turning points, any way you call it, just that the gradient at that point is 0. Thanks for joining this class. Don't forget to like, subscribe and share. More questions will be solved in our future videos.